Welcome for the video lesson for the tangent ratio day 1. We're going to be discussing how to find the tangent ratio given an angle for a right triangle or given the sides for a right triangle. Let's get started. Our tangent ratio is going to be representing the slope of a hypotenuse for a right triangle. Or another way to think about it is it's going to be telling us how steep the hypotenuse is. So we can call this the percent grade of our hypotenuse. For our slope, traditionally we know that it is the rise over the run. Let's apply the idea of slope to our triangle to help us identify the slope for our hypotenuse. If we start at angle A, and we know our hypotenuse is from A to B because it's across from our 90-degree angle, we can find the rise of our hypotenuse by looking at side BC, and we can find the run by looking at side AC. So the ratio of BC over AC would give us our slope for our hypotenuse. Some terms that we use a little more often than rise and run when dealing with triangles are going to be opposite side and adjacent side. And these are going to reference the angle that we're looking at. So if I'm starting at angle A and I go across from that, I now have my opposite side. So not only does side BC represent the rise for our hypotenuse, it also represents the opposite side for our angle. And then my adjacent side is going to be the side that is not the hypotenuse but helps form my angle. So AC will be my adjacent side. So I can take the idea of slope and rewrite it instead of rise over run as the opposite side over the adjacent side. We're going to go ahead and practice identifying opposite sides and adjacent sides for our angles to help us find the slope of our hypotenuse, which represents our tangent ratio. Looking at our triangle, AB is going to be our hypotenuse, so the slope of that hypotenuse will help us identify our tangent ratio. And there's two different ways that we can identify our tangent ratio. In this example, because we already know what our angle is, we're going to go ahead and use a table to look up the value of the tangent based off the angle of 35 degrees. So let's go ahead and look at that table real fast. Going back to our question here, again, the table told us the answer is going to be approximately 0.7002. And let's talk a little bit about why that happens. If you look at our tangent ratio, we know that it is going to be the rise over the run for our hypotenuse, or the opposite side over the adjacent side looking at a reference angle. I'm starting at angle A. So from angle A, again, we know that BC is going to be my opposite side. And I also know that AC is going to be my adjacent side. Another thing we can kind of look at here visually is BC is going to be smaller than AC. So since my numerator is smaller than my denominator, that tells me that my tangent ratio is going to end up being something that is less than 1. And we saw that with our answer of 0.7002. To finish up our problem, we're going to go ahead and find the percent grade for our tangent ratio. So if I take my ratio and I multiply it by 100%, I can then convert it into the percent grade and end up getting 70%. So we can talk about a ratio as either 0.7 for the tangent ratio, or we can say the percent grade for our tangent is 70%. For our next triangle, we want to find the tangent of 45 degrees. And one thing we can do to help us with this problem, knowing that we have an angle of 45 degrees and it's a right triangle, I automatically know that my other angle is also going to be 45 degrees, which means this is one of our special triangles that we learned about. If we're talking about the ratio of sides, I know that across from my 45-degree angles, the ratio is going to be 1 and 1. And then for the hypotenuse, it's going to be root 2. If I want to identify the tangent of 45, again, from that angle, I'm looking for the opposite side over the adjacent side. And conveniently, my opposite side is 1, and my adjacent side is also 1. Which means for my ratio of the tangent of 45 degrees, I have 1 over 1, which is 1. If we want to go ahead and take our tangent ratio and find the percent grade, again, what we're going to do is multiply by 100. So if I take 1 and multiply it by 100, then I get 100%. So again, my percent grade is 100%. In example 3, we're going to attempt to evaluate the tangent of 58 degrees. Unlike the last example, 58 degrees is not one of our special reference angles, so we're going to go ahead and use our table again to help us identify the tangent of 58 degrees. All right, again, when we're using our table, we're going to look up our angle first. We know that we have a 58-degree angle, so I'm looking at this row. I'm also trying to identify the tangent, so I'm looking at that column, and I get 1.6003 as the tangent of 58 degrees. From our table, we identify the tangent of 58 degrees as being 1.6, and we're going to go ahead and verify that again, that answer is reasonable based off our triangle. If I'm looking at my angle for 58 degrees, I know that PR is going to be my opposite side. I also know that RQ is going to be my adjacent side. If we quickly visually compare our sides, we can see that PR is visually larger than RQ. And since our ratio is going to be opposites over adjacent, it's going to be PR over RQ. Knowing that our numerator is larger than our denominator supports the fact that our tangent should be something that is greater than 1. And once again, if we want to find the percent grade, we can take our ratio here of 1.6. I can multiply that by 100. And I end up getting 160% for my percent grade for the tangent. We're going to go ahead and use our steepness scale here to generalize the tangent ratio based off of a given angle. To begin with, we can define the tangent of 0 degrees to be 0, because that's going to represent a flat angle, something that's essentially just on the ground. As we are increasing our angle, going from 0 to 45 degrees, our steepness is going to slowly increase, and it's going to slowly increase because the ratio of your opposite side over your adjacent side is increasing until it gets to be exactly 1. And that we saw with one of our previous examples where we had a special 45, 45, 90 triangle, and we saw the ratios of the sides gave us 1 as our tangent. After 45 degrees, as we go from 45 to 90, again, your ratio, your opposite over your adjacent, is going to continue to increase past 1 until we get to 90 degrees. And at 90 degrees, we actually have a unique situation happening. At 90 degrees, the tangent ratio is actually undefined. And the reason why it's undefined is if we think about a 90-degree angle, we have a vertical line. And the slope for a vertical line is, in fact, undefined. So again, just to summarize, we start with a tangent ratio of 0. As we get closer to 45 degrees, our tangent ratio is getting closer to 1. And then past 45 degrees, our tangent ratio again increases until we get to 90, where we have an undefined tangent. The second method that we can use to help us find our tangent is if we know our sides. Using the ratio of opposite side over adjacent side, and starting with angle A, I can identify the values for my ratio. So if I start with A, my opposite side, again, is going to be 8, which makes 15 my adjacent side. I know 17 is not one of my sides to use because 17 is my hypotenuse, and my ratio only uses the opposite and the adjacent sides. So to find my tangent, I can say that the tangent of A is going to equal 8 over 15. If I convert that into a decimal, then we end up getting approximately 0.53. Now what we're going to do is use that value and attempt to find angle A. So we're going to do the opposite using our table. Instead of starting with our degree on the outside and trying to find the ratio on the inside, we're going to use the ratio on the inside and trying to find the degree on the outside. All right, from our example, we know that the ratio simplified to be approximately 0.53. So that's the number that I'm trying to find on the inside. I know I'm looking at the tangent ratio. So I'm going to look at that column and try and identify where 0.53 is. And if I scroll down, I see that it's getting larger until I finally get to approximately 0.53. So that's going to be my mark there. And I want to go out to the angle, and it looks like my angle is 28 degrees. So I can then say that the angle for a tangent ratio of 0.53 is 28 degrees, which means that angle A must be 28 degrees. For our next example, we have the same process. I'm giving all of my sides. I want to use those sides to help me identify the tangent ratio, and then use that ratio to help me identify the angle. So looking at angle C, I have my opposite side, which is 40 degrees, and then I have my adjacent side of 30. Again, we know that 50 is not one of our sides because it ends up being the hypotenuse. And a ratio is always the opposite side over the adjacent side. So filling in our values, we have 40 over 30, and that's going to simplify to be approximately 1.33. So we can say the tangent of C is equal to 1.33. We're going to go ahead and use that ratio now to help us find the angle. So again, like the last example, I'm going to identify the column for the tangent function, and I'm going to go down until I see a value of 1.33 and then go out to see what angle it corresponds to. Since my ratio is 1.33, I know that's bigger than 1, so my angle has to be bigger than 45 degrees. So I'm going to start over here on the second half of my chart, and I'm going to scroll down until I see approximately 1.33. So I'm going to keep scrolling down and it's going to be between 53 and 54 degrees. And if I look at 53 degrees, it's 1.327. So that's pretty close. So I can then say that my angle, so we have the measure of angle C, is approximately 53 degrees. All right, here's our last example. Why don't you go ahead and take a moment to identify the tangent ratio using the appropriate sides, and then go ahead and use the table to see if you can identify the correct measure of angle Z. Go ahead and pause now and attempt to find those two values. All right, let's see how you did. So looking at my triangle, I identify that my opposite side is 14 and my adjacent side is 48. So from a ratio, I have the tangent of Z is equal to 14 over 48. And when I simplify that, I get approximately 0.29. So the tangent of Z is approximately 0.29. If I use that in my table and I scroll down in my tangent column to see 0.29 and then I go out to the angle, I can see that angle Z is going to be approximately 17 degrees. Well, that does it for tangent ratio day 1. Go ahead and check in tomorrow for tangent ratio day 2 video lesson.